come here to Romania. Ladies and gentlemen, welcome to my presentation about computerized axiography. It is an interactive presentation. I will do a little bit on the computer and I will show it in really on my human being. I'm a medical engineer. I worked for 35 years for Kevo in R&D department. And in '79, I was the first designer for electronic pantograph. It was a study that at this time it was too difficult to make it electronic-wise. The electronic was not so far as today. So it takes a long time to make it as easy as today. Now what is the problem? The problem is, for the most people who use computerized axiography, is to find a good result if they work in crown, bridge, implantology, to have a right function. To anterior guidance, the teeth must design to match with the jaw movements. So for this we have to know jaw movements to shape the right surface of the teeth. Look here, we have an interactive system for the students. Here we see the problem. The patient's movement is controlled by the jaw guidance. We see here the jaw guidance with the discus articularis. It is controlled by the teeth, here in this case the front teeth. And these both guidance, jaw guidance and teeth guidance, are responsible for dissolute, the molar and premolar. But if we change, or we don't know about perhaps the jaw movements, we change the jaw movements, we see immediately the problem in the section of molar and premolar. Or if we make a new crown, front teeth, we change the front teeth, we see still the problem. These are dysfunction, the controller, condyle inclination, or the teeth guidance is not in function with the teeth morphology. This is what we use in universities as a teaching tool. Now the problem nowadays is the material. In the old time it was not a problem. If we have amalgam, we have gold. If we have not the right function, it was not so critical. But nowadays we see many, many problems with the ceramics. We see chippings worldwide, chippings problem. This is another problem with the ceramics. There's also another problem with the dental technician. This is a function problem. If you have not the right function, you have chippings. And it's not possible to grind in. If you grind in, you can do it of course, but we know we lose more than 50% of the hardness of the ceramics. That's the problem of the ceramics. Beautiful, but in function, we have many troubles. Here the same situation, and we see here also chippings. This is the problem of the ceramic, and you have not enough good function. Axiography versus 3D navigation. What I show today is not axiography. Axiography is just to control the jaw movement. This is not 3D dimension. This was in the past the possibility. Nowadays we have 3D navigation systems, much more precise. It's a 3-dimension navigation system. On the right side you see the ARCUS Digma navigator. It's a 3D navigator. The background comes from the military, from the navigation. And this is different to normal axiography. That's important to understand. Recording the individual patient jaw, not only the axis movement, calculating the articulator settings for artificial joint, simulate all the movements for the patient to reconstruct the occlusal surface. Here we see the system on the patient. Together with an electromyography system, we can also connect electromyography. So we see during the measurement, if you need it, also the muscle activity. It's not necessary, but you can do it. The system is fixed, or it's a connection of the face bow, of the cable face bow. On the left side you see the face bow, on the right side you see the measurement system. The face bow has a sensor system, and that's it. It looks like a face bow, but it's a 3D navigation system. But it works in the same way. We integrated the system directly in the patient chair, in the treatment unit, because all the systems have to be used immediately if the patient is on the chair, so we fix it directly in the unit. Special also for TMG disorders and muscle activities. To fix the system, we only need to fix on the head with the glabella. We fix it above the ear, not in the ear, with above the ear, because there is no soft tissue. Here we can fix the system. And on the back side with a special band. So we have a stabilized position of the sensor system on the patient head. And this is the upper bow, one part of the navigation. Then we need a lower bow. The lower bow is fixed on the teeth para-occlusal. It means we can measure jaw movement, teeth guidance, all together in one step. So we fix it with a glue system on the teeth. The system has only 33 grams, so it's very soft. There is no contact between the systems. Lower and upper is without any contacts. So there is no influence from the heavy of the sensor system to the patient. The same is if you have full denture, edentulous paper, then we can fix the sensor in the wax ball. Normally we also use an oral pin. The oral pin is responsible to press the system on the soft tissue. So we can work also in the full denture area. Or you want to disconnect occlusion to measure centrifugation. Now how does it work? It's an ultrasonic navigation system. We fix on the lower ultrasonic sensors. This sensors gives a small peep, you don't hear it. And on the head we have 8 ultrasonic microphones. And each sensor sends his signal to 4 microphones. So at least we have 16 lines to control the lower movement to the head of the patient. So we can control the mandibular to the maxilla in 3 dimensions. And we measure 50 times per second. This is necessary to see all the jaw problems. We need a high frequency, 50 Hertz, to see what's going on during the movements. And if we have make the measurement, then we see the jaw movement in 3 dimensions. From all sides we see how does he work. We get all the coordinates. By the way, we have all the coordinates as ASCII data file for the research. That is the reason many universities use it for research, because with this system now you are able to document all the different 3D movements. Perhaps the puzzle diagram from the front. If you want to see and go to the back, then you see immediately the incisal movements, the jaw movements from the side and from the front. Or you see in isometric also the movements here to see what's going on. software. It's on a computer. It's a net software. It means you can install on each computer in your office, and everybody have the possibility to overtake the data. Also in the clinic, it's a big net software. And all the data you can import in the database, you can export, you can send the data to your colleague and ask him about what do you think about this problem. So this is an international network now to help dentists to see in TMG function or TMG problems. Can it print out, send it to a laboratory or any documentation, and we have also a record replay function to see all the 3D movement after the measurement. The whole machine, you see it, is in the hand of the dentist. It's a small machine. It's an integrated computer, and we can fix it on the unit. It's a standalone version. We don't need the keyboard of a computer. This works alone. This can be disinfected. This is a medical product in the hand of the dentist. We see here a touchscreen monitor. And if you see now the monitor here, you see the different programs, what I can doing with the system. Most of the people, I think 85%, use it every day for Articulator program. We have many clinics, private clinics. We have also a private clinic in Budapest. 8 dentists have 8 systems, each chair has a system. Since they use this system, they have double guarantee of function because they know there is no more any problem because the system measure it, the dentist can, or the dental technician can reproduce it, and they have a very, very good function. Then we have 4 different software modules to help the dentist to find out where is centrifugation and where is centric occlusion. He helps, he visualizes the position of the lower jaw to get in the end and registration, and he see what is in the registration. It's a difficult field, but with the system, I believe we are much better in the daily work of dentists. Then we have 3 different programs for diagnostic. The motion analyzer is a documentation system. You can measure today all the movements. You can make half a year later an overlay, and you will see before and after therapy what's the difference. He helps to make a diagnostic, and he helps to make a documentation before and after therapy. Here we have a special pain finder. We have a system who helps if we have a pain problem in the jaw. He helps to find out where is the point position of the jaw, and also we can find out together with the patient why he goes in this position perhaps. Is the proximal left and right, or what's going on? This was designed or is designed by Professor Axel Buhmann from Berlin. Electronic position analyzer, this is a comparison system who gives you the information of the bite, different bite positions. And last but not least, the biofeedback we can use during the measurement. An electromyography system, we can measure temporalis or masseter on both sides, and we see left and right the difference or not difference during centric occlusion, then during centric, during movement, and so on. When you talk about jaw diagnostic, we can follow the condyle, not the discus, clear. But look here, if we see without a positioning, it looks like here on the screen now. This is the problem. If we have a patient without the repositioning of the discus, we have normally this kind of a situation. And this situation we see on the Digma like this here. we get an information. The right side makes a normal movement, and the left side we have a short movement. This short movement is the information for us. Normally, the discus is in front of the condylus. We have not enough movements, or we see different curves. But most of the time, we see this kind of information. The different diagnostic information is we have a repositioning of the discus like this here. This is a visualization of this. To see from the side. Or we can also see from the view. And on the Digma, we see this kind of loops. These loops here are normally the information of the up and down of the condylus of the discus movements. At the moment, we're working on a connection between the measurement system and the DVD, so we can also make an overlay in the DVD to see it also in the DVD or in the MRT. To program in the Articulator, this is the easiest way to use the system. We have here a program to program the Articulator and the lower jaw position. We use in this case a special key. It's a kind of a byte fork. On this byte fork is the calibration key for the system, the patient byte in this system, the sensor is on the system, and this is to calibrate where are the sensors on the head of the patient. Here we see the system in the Articulator. This byte fork is in a known position for the computer, in a known position. And if you have a three-dimensional navigation system, then you can mount the model in this known position, and the computer will tell you what you have to adjust on the left condyle, on the right condyle, and what you have to adjust on the incisal film. These 3 points can be programmed under the known position of the computer, but only if you have a three-dimensional navigation system. The procedure between Facebook or ARCUS Digma is nearly the same. The difference is that Facebook is just the position, the upper model. The navigation gives you the position and all the adjustments in left, right, and in the incisal point. Here we see the paper who will be produced by the system automatically. We measure the condyle inclination, we measure the bended angle, the immediate side shift angle, all what is necessary to program an Articulator in 3 dimensions. And we also measure the teeth guidance. The blue lines are the teeth guidance, and we adjust the full adjustable incisal table. These 3 points are responsible to reproduce the lower jaw movement. Some people measure how precise is this system. It was in 2016 in Hanover, and the research was about, let's have a look, 30 people, and they want to see, is it possible to reproduce movements? Is a patient possible to reproduce the movement and the system? And also they want to see how good we can record also people with TMT problems. The result was, here I see here the result was, we can reproduce the measurement less than 2.1 millimeters accuracy in the condyle inclination. It's much better than you can adjust the Articulator. And also the TMT problem, people have a good result. I think it was here 2 degrees, 2.3 degrees. So the system is very precise if you make the measurement again and again and again on the patient. One of the reasons is there is no contact between upper and lower, and the lower bow is only 36 gram. So there is no influence of the movement of the patient's head. We have a time consuming. This was a research from the University of Zagreb, I think in 2011. And approximately, he tells us 25% of the time we can consume if we work with a system like this, against if you work with Facebook and adjustable articulators. It means if you have all the data, you have a much quicker work. The same was also in San Diego last year. There was a research about bite registration of occlusion splint therapy, and he also told us if you work on this system, you save nearly 40% of the time if you have all the measurements. This was University of Zagreb. So much for today. Nowadays we work the next step. It means the virtual articulation in CAD/CAM. The system now also measure the system and support CAD/CAM system, of course. In this case, we have the measurement system, we have the scanner who scan the both models. And here we see now, driven the both models from the Digma here. So we have all the 3D information directly in the computer without any mechanical articulator, and the data go directly through from an Axiography system and control the both 3D scans to reproduce precise in CAD/CAM technology. Here we see perhaps through a 4.6 CAD, and we see how does the teeth moves during a latitrusion. This is driven by the Digma system, and it's shown as a scan. This will be support the CAD/CAM system, so we are able to have the right occlusion because we get a measurement and the virtual wax up, and the computer will equalize all the problem if there are any movement problems. But you have to measure before in 3 dimension the lower jaw movement. This is the non-working side. This is, by the way, 4.6, a cut to 4.6. Or even cut to the fronties. Here we see a cut through the fronties. Fronties guidance, you see the fronties guidance until head bite, controlled by the system and backward. This is now possible because the new technology allows to measure precise and reproduce it with the scanner. So the computer will now control the occlusion. It will change a little bit the occlusion, so we have now the right function under the help of the navigation system. Here we see the cut again. It's the cut through the fronties. So we have now 2 ways today. The normal way is we work with the face bow, we make preparation, impression, go to the articulator, scan the models, go to the wax up system, and the computer will cut function. This is the classic way. Or we take the new digital way. We measure with the Digma system, make the cut on the teeth, go to the scanner, EO scanner or normal scanner, go to the virtual articulation, computer overtakes this part, and then we get 3D produced